Okay, so we do a tutorial today in which we look at both the lectures that we have studied so far. First we start with this tutorial on aircraft component nomenclature. This tutorial is based on a recent visit that has been conducted by us. So what are we going to do here is we are going to explore some interesting components, but these components are not from the fixed wing aircraft about which we spoke last time, but from 4 interesting helicopters. So during our recent visit to Juhu Aerodrome, which took place on 15th of June, we visited this aerodrome. Okay, so this is a proof that we actually went there, and we went to 2 companies. One is Raymond International. They had 2 helicopters on display at that time. These are being maintained. And we also had a look at the Tata Power Company, where they also had another 2 helicopters. So the major discussion that will take place in this tutorial is about these 4 helicopters. And then in the end I will show you another interesting aircraft. So let us have a look at this picture and see if you can find some familiar components. Okay. So for instance, what do you think are these? Yes. How can you say it's a pitot tube? So anything in the front of the aircraft is a pitot tube. It could also be a pitot static tube. Is there a difference between a pitot tube and a pitot static tube? So don't worry, we will study about it. Okay. Okay, right. Then what about the thing on the bottom? Yes, that's a radome, correct, that's a radome. So there are hints. So part 1, we also asked them to open it and show it to us. So you can see this is a scanning radar. So yes, it is a radome, and therefore the material that was used to make that part is not metallic. It's a glass fiber composite, if I remember correctly. What are those lines? Those black lines? 2 lines are there because we are pointing out at them, but on the radome there are these lines painted. Yes? But notice they start from the front and end before the end. There is no continuity to the structure. The one on the left and the right, there is no continuity. They start from the front of the radome and they end before the radome ends. Correct? So do not jump to conclusions and do not give a lot of wind to your imagination. It's a good attempt, but that's not the reason, that's not what it is. Okay. Anything else? Yes? For visual indication, so that no one steps or hits it by mistake. That's what it is. It is just a visual indication to prevent bumping. That's why it's a weak structure. It doesn't have any backing part inside. So even if somebody kicks it, there can be a damage. So it's just an indication. I don't think there is any technical significance to that part. Okay. Right. Let's see what is the second part. That's a pitot tube cover. Now we know it's a pitot tube because we saw static ports mounted on the side of the fuselage. So it's a cover. Alright. There are 2 parts which have been sketched. Okay. Now this is a bonus question. I must tell you one thing, that even I had no idea what these parts are. With so many years of experience in aviation, I had no idea. So hang on a minute, experienced people will come to you last. Can the students try to guess what are these 2 jutting parts, one below and one above the helicopter? One of them is on the below, on the bottom side. The other one is on the side, top side. So what could these parts be? Yes? No, they look like antennae, that's what I thought, but they are not antennae. Yes. They are? No. It's a good guess, but why would you have one below, one above? And let me tell you, both of them are functionally identical. So how would these 2 parts give you vertical speed? No, they are just metallic pieces. Yes. No, no, they are not lights. Lights are mounted in a much bigger, they are much larger. Yeah. Above the helicopter, you want to have a tail skid. No, look, listen. Both the parts are functionally identical. Therefore, if one is a skid, the other cannot be a skid. And how can you have a skid on top of the helicopter? Think before you answer. Think before you answer. Yes. Above the door and below the fuselage to open the door. And why would it be such a horrible shape? If it is a door, it will be a handle. Yeah. He is coming near to the answer. Can you now guess? That's right. Wire strike protection system. When helicopters fly at low altitudes, they may encounter these kind of wires. So those two devices above and below helicopters are basically going to protect the helicopter from getting entangled in these wires. So this is a very interesting component, wire strike protection system. Alright, okay. What's this? The thing on the bottom which is curved. So is it an antenna? Is it a pitot tube? Or is it a towing hook to move the helicopter back and forth? What do you think? The answer is none of the above. So what is it? Yeah. Drain pipe, that's a good guess. Drain pipe for draining out excess water. But look, it's coming from the light. So it cannot have any water elements near an electrical component intentionally. By this way you will short the light. So not a drain pipe. I'll add that fourth point there. What do you think? Look at the location, look at the shape. It's not pointing forwards, the helicopter is actually pointing towards the left in the figure on the left. Yeah. That's what people think, it's an electrostatics, it's not. It's just a tail skid. It is just a tail skid, a device which will protect the helicopter rear boom from hitting the ground. Now this is a very special helicopter. I also wanted to observe the mounting of the horizontal tail. You can see a vertical tail with a red strip. You can also see a horizontal tail. And this horizontal tail basically is mounted in a particular fashion. About that we will come again later. Okay. What do you think are these parts? The one on the left which says do not hold. It looks like a handle, but it says do not hold. And the one on the right is a simple giveaway. Anyone can guess what these parts are? Okay. Both of them are antennae. Okay. Right. Now, here we see inside the cockpit there is a stick which seems to be bent. It seems to be having a curvature. So what is this stick and why is it bent? Yes.
It can move in 4 ways. That's why it is bent, so as to give clearance to the driver's leg and seat.
Yeah, pilot's leg, please.
Sorry, pilot.
Yeah. Okay, but pilot is also a driver anyway. It's not a problem. You are not technically wrong, but we call the pilot, the driver of a aircraft as a pilot. So yes, this is to clear the knees of the pilot because there is a situation of very cramped operation in the helicopter, and this is the helicopter yoke which is used for giving the command, except one on the bottom. You can see on the right picture there is a shaft like thing on the bottom that is meant for the collective pitch. I'll talk about this when I talk about helicopters. Okay, this is a very interesting component and we were given a huge description about this component and its cost implication, etc. I must give you some hints. This component is recommended only for India or mainly for India by the helicopter company. It was not there in the original design. When the aircraft was sold to countries like India, then they have recommended installation of this particular system. It's very expensive. What is it and what is the purpose? Yes, mic please.
Is it a radiator?
What do you mean by a radiator?
The temperature under the hood can get quite toasty, so it's there to
decrease it?
No, it's nothing to do with heat transfer. No, it's not a radiator. It's not a radiator. Anybody else? There is a very fancy name for it, and it is pretty expensive. This is nothing, but anybody else want to guess quickly? This is basically a dust cover. Okay, but it's a very high fidelity dust cover. It has got some active chemical inside which doesn't allow the dust to go in. They observed that when helicopters are flown in countries like India, because of the tropical climate and the presence of dust and other particles, the engine was sucking a lot of undesirable elements. And when you put a filter, sometimes the filter gets clogged because the particles just stick. So they came up with a very interesting design where there is some kind of a fluid which is put in this part and it repels the dust. So it's a very expensive item and it has been recommended. It took about a couple of months to get it retrofitted in the helicopter. Alright, this is the photograph of the tail rotor. You can see that one rotor which is facing the camera, or I should say cross sectional of the rotor is visible in the camera, and then there are two of them which are bending down like this. So why are they bending down? Aren't they supposed to produce lift? Aren't they supposed to be horizontal? Why are these rotors bending downwards? Yes, just a minute. No one here can guess why are they bending down? Yes.
Sir, they are bent down due to its self weight, and they are intentionally bent down so that in the case of producing lift, they must not go up like this.
Okay, so they are bending down
Like
just because of their own self weight. That's all it is. It is just because of the self weight, and when they start spinning, they will generate lift force, and that will actually create a lot of stress. So this particular weight actually will act as a relief. It will be in the direction opposite to the direction in which the load is coming. What do you see at the edge of the helicopter rotor? There is a small metallic strip with two nuts very clearly visible, and only in the front part, only in the front half. What is that and why is it there? What do you think? Just a protection. So the most common problem in helicopters is when they fly in small areas, the tail rotors start hitting. It's not that if something hits the rotor it will not break, but if it just scrapes the rotor, at least this thing will give some protection. Okay. This also may be an access, providing access to some internal areas of the helicopter rotor for maybe maintenance purposes, observation, oiling, etc. I don't know, but my guess is that this is just a protection plate. Yes. Why this metal? Yes, because helicopter rotors don't turn in the opposite direction. They turn only in one direction. So if something is scraping, the front part will be hitting it first. Okay, that's why they have put it only on the front half. Okay. Now this figure is not a question. This is just to give you an idea about how complex the tail rotor of the helicopter normally is. Okay. And there is a reason why I am showing it. See, notice there are two links here, one on the top, one on the bottom. Okay, these allow this whole assembly to move forward and backward. Then we have one link here and one link below. That is meant for changing the angle of the rotors together. Okay. Then you can see there is something here and there is something here. What are these? What do you think are these? And there is a kind of an angle here which allows you. So what is that? Yes? Yes? Coupling, that's a coupling. So because it's a rotating part, now from the main helicopter rotor shaft there is a shaft coming and then it turns 90 degrees in this case and then it couples to the shaft on the, so it's a very complicated system. So if possible we should get rid of this complicated system, if possible, if it is feasible. But why do we need a tail rotor in a helicopter? Why is a tail rotor essential in a helicopter? Let's have some new people. Anybody would like to answer? Yeah.
Angular momentum.
Angular momentum. Can you explain?
Like the main rotor starts rotating, the helicopter tends to counter rotate.
So it is basically meant to counter the auto rotation of the helicopter body when the main rotor rotates. So you put a rotor on the back, give a force to counter that. So the moment created by the tail rotor is just enough to overcome, unless you want to intentionally move to the left or right. Okay. So that's why the RPM of the main rotor and the tail rotor, I mean the rotors have to be coupled, because as you increase the lift or the RPM, you have to also have a corresponding change. So it is complicated, and this is the most common reason for mechanical faults in helicopters. It's a nightmare for maintenance. So we will see how people have attempted to modify this. I also was very intrigued to see these kind of cuts. So you see the side view of another helicopter from the Raymond's hangar. You find that the tail rotor, there is one member jutting out here. You can see it here also prominently. Okay, and then you see this very interesting shape on the tips. Similarly, I took a photograph, not me, one student who went with me took a photograph of the tip of the main rotor. So these are required for manipulating the tips, because the tips have tip vortices, as we will study, and providing such shapes helps in reducing. Now, this is the photograph of the horizontal stabilizer of one of the helicopters, and I observed that the top is flat and the bottom is curved. So I told, you have made a mistake in mounting this. It should be upside down, right? Because we never see airfoils flying like this. So what is the reason? Is it intentional? What do you think? Is it a mistake or is it intentional? What do you think, Amri? It is intentional. Nobody makes such mistakes in aircraft design. Okay. That means, what will happen if you have tail upside down like this? What is the result of this kind of a mounting? Downward force. Tails don't produce lift. Tails produce a force for balancing the aircraft. So there will be a lift by nature is considered to be upward. So if something is not upwards, we don't call it lift generally. Okay, because it doesn't lift. So it's pushing down. So from the point of view of balance of the helicopter, you needed a downward acting force always or mostly, and hence they have mounted it upside down. The same thing you also see in aircraft. When I saw the aircraft DO-228 for the first time in the hangar, I also was surprised. I found the tail to be mounted upside down. And that's when I remembered the course of stability and control, where I was taught that generally the tail carries a downward force. So the one good way of doing that is to mount it such that it gives you downward force. This is another helicopter. This is the helicopter in the Tata International hangar. Incidentally, this helicopter is personally flown by Mr. Ratan Tata. He flies it himself. Now I don't see a tail rotor here. So has it gone for maintenance? Or is it not there intentionally? What do you think? Where is the tail rotor in this helicopter? Both sides are only fixed vertical tails, and there is also a very small horizontal tail, and also you can see a small tail skid, the white one, but the rotor is missing. So what is the reason? Yes. No, it doesn't have a twin rotor. You are very right. If you have two rotors which are counter rotating, like in the Kamov helicopters with the Indian Air Force, yes, you would not require a tail rotor. But I think if you had seen some earlier pictures, I don't know whether we have some earlier pictures of this helicopter, maybe I have to just search. But believe me, it has only one main rotor. So it doesn't have two rotors. Controlled by jet, which the jet from the exhaust of the engine? No, that's not the thing. This helicopter is very interesting, yes. The exhaust gas from the engine, yeah, that is the exhaust of the engine, correct. Yes, at the tail, that means somewhere here. So you mean to say that, but I see the exhaust is here. There might be, okay, there might be, but no, this is not an exhaust hole. So that's not the reason. Okay, this helicopter is called as a no-tar, which means no tail rotor. That is the selling point of this helicopter. So what they do here is they use an effect called as a Quanda effect, about which we will study. When I come to that portion, I am going to elaborate to you on that. So yes, there is a small duct, and a small outing on the bottom. Okay, and this particular you can say assembly rotates also, but we don't have the engine exhaust from there. So we don't use that for, I'll explain this to you when I come down to the Quanda effect. Okay, after this we went to the Bombay Flying Club, which is located in the same Juhu airport, and this is a very historic aircraft behind us. This is considered to be Asia's oldest aircraft which can still be flown. It was fabricated in 1940s, brought to India in 1951. It came to Bombay Flying Club in 1955, and they have maintained it from that point onwards till today in a very perfect condition. So look at this picture. Can you think this aircraft was 1940 aircraft? 65 years of service. It was also flown by J.R.D. Tata himself. So such a historic aircraft is available in Bombay Flying Club, and we were very fortunate that on that particular day we were able to go and have a look at this particular helicopter. This gentleman on the white shirt to my left is Mr. A.K. Ajay Kumar Bahadur, who is the chief engineer of Bombay Flying Club, and he was our host that day for this particular trip. So first we went to the two helicopter companies, and then we went to this place, and then they also gave us a very nice lunch, after which we came back. Alright, so that's it about the first capsule.